Everything is going electric. We're not going back to steam or fossil fuels. The main driver of electrification is simple. It is a better way to build high-value products. Even the oil guys admit it. All electrification applications have one thing in common. They need batteries. We are not talking about AA's or lead-acid batteries from the old days. Only lithium-based batteries can hold the energy required to power serious commercial and industrial applications of the future. But building battery packs using lithium cells is actually difficult and dangerous. When managed poorly, even end users can get hurt. We see battery fires on the news all the time. Plus, lithium is a valuable mineral and a finite resource subject to the laws of supply and demand. If not properly managed, electrification at scale will become economically unviable for many applications. It takes anywhere from hundreds of thousands to millions of dollars and months to years to develop a high-performance custom battery solution. Also, companies must hire teams of skilled engineers with expert knowledge in a highly sought-after market. The time and cost really put a damper on businesses which are always under immense pressure to do things faster and cheaper. Moreover, companies have no choice but to divert resources from building their product to building battery packs, which does not help them to differentiate. Despite the cost and safety concerns, most companies do it over and over, building custom battery packs for their products and applications simply because there has been no other practical way. It is really time to stop reinventing the wheel. We examined all the common challenges associated with product development and electrification and invented the Tanktwo battery operating system. Here's a simplified analogy to illustrate the profound changes the battery operating system will bring. When you bought a personal computer in 1982, you would expect to spend north of $10,000 in today's money on the hardware like the CPU, memory, the hard drive, the display, the legendary Model M keyboard, and so on. The operating system and some basic software came with the hardware at no extra charge. Until the clones hit the market, this was very good business for IBM. Fast forward 30 years. IT hardware is a cutthroat business exclusive to Asia, and virtually all of the profit in IT has moved into software and services. It is the same today when you buy a battery pack with an expensive device. You pay for the hardware, the lithium, the can, the wires, the plastic packaging, and so on, but nobody thinks they should be paying for the software in the battery management system, without which the device would burst into flames the first time you plug it in. We are at the tipping point where a change in attitude and value is about to happen. The focus of electrification will shift from the materials and packaging to a data and algorithm-driven environment where the software will optimize the value of the hardware. Why the shift? It all comes down to dollars and cents. The amount of money spent on making battery packs smart will be offset by a large margin through the reduction in material costs. Using fewer materials also means manufacturers are less susceptible to supply chain issues, and the production process becomes more environmentally responsible. Who doesn't want to do more with less? Smart battery packs will drive the future of electrification. So how do we make our battery ecosystem smart and universal if different applications have different criteria? How do we allow our customers to create customized solutions and scale at the same time? Again, the answer lies in the software-driven and hardware-integrated ecosystem approach, which is not unlike how Android works today. We have identified functionalities required by various high-value battery applications. These include basic functionality, serviceability, reliability, safety, the total cost of ownership, and of course many more. We not only designed the hardware but also built the software required to drive each class of functionality and neatly put it into a middle layer, which acts as a plug-and-play interface between the cells and the application. Make the battery behave in various ways to meet different product requirements. The product essentially named itself. We just had to call it the Tanktwo battery operating system. Let's illustrate the concept with a few use cases. For an application in the aerospace industry, the total cost of ownership of battery packs isn't of the highest priority. Instead, manufacturers would trade that for higher serviceability, reliability, and safety. TBOS allows our customers to build their battery system to meet those specific criteria by making more extensive use of an aerospace-focused subset of TBOS features. For applications in industrial environments, like warehouse robots, businesses may prioritize flexibility of implementation and service personnel safety. Meanwhile, for more high-volume applications like electric vehicle fleets, the total cost of ownership, end-user abuse proofing, and field serviceability may be the primary focus. Clearly, a battery for an electric delivery van doesn't quite need the same level of reliability as an airplane or a space vehicle, so its feature set will naturally be balanced differently. We give our customers who build the products the ability to select the functionalities they need for their applications to the degree that they need them. In the next video, we will dig deeper into how our battery ecosystem works and why it is so unique. Meanwhile, if you want to learn more about this investment opportunity or have specific questions about technology, feel free to get in touch.